morning. So this is the second video on the same problem, straight bar. So here we will use the beam element instead of the link. First step is go to the file, clear and start new. Then go to the preferences, select the structural. Then second, preprocessor, element type, add element, add. Now instead of link, you can go to the beam and select the 2 node 188. Okay, so just we will add the one element. Now for the beam element, we don't require the real constant, so skip the second step and go to the material property, material model, structural, linear, elastic and isotropic. So for the first element, Young's modulus is 200 gigapascal. So it is 200 e to the power 3. Poisson's ratio is a 0.3. Okay. Material, new model. For second material, isotropic, it is 150 e to the power 3. So basically e to the power 3 means it is 150 10 to the power 3 Newton per millimeter square. It's 0.3. So we have added two elements. One is 200 and second is the 150 gigapascal. After material property, we have to go to the section. For the beam element, we have to add the cross section. Select the beam and common section. So here we have the different sections. So here I will select the circular cross section. So here we have two different cross sections. So for the first, you can give the name. So cross section 1. Cross section is a circular. Now instead of the area, we have to specify here radius. So just I will assume some radius. So for example, the first radius is, suppose it is 20 mm. Okay, apply. Second, you can give the cross section 02 and radius is 10 and apply. Okay, so we have created two different cross sections for the beam. Now we have to model the elements. So go to the create first key point in a coordinate active coordinate system. First one, so you can see here this is 200 and first is 0, apply. The second is a 200, apply. The third one is 300, apply. So we have created the key points. So basically the key points are the end points of each section. So key point is related with the geometry. After key point, you can create the line. Go to the line, straight line. Okay. Now instead of key points, you can directly create the node and element. Okay. So if you create key point and line, we need to discretize it. So for the discretization, go to the meshing, go to the mesh attribute and default attribute. Now here you can see we have two elements, so two materials and two cross sections, so 1 and 2. Okay, so first select the material number 1, cross section 1. Okay, now go to the mesh tool, go to the meshing by line, select the first line. Okay, now here you can use number of element divisions. So if you select 1, then it will create just one element. So if you want more accuracy, then you can discretize in a 10 number, 20 number. Okay, so just I will take this as a one element only. Okay, click here, again go to the mesh, select the same line, and okay, now the mesh is applied. Just zoom out. So here we have the second element or second line. So again select the mesh attribute, default attribute, select here second, select the cross section 2. Okay, now go to the mesh tool, again go to the line, select this. Okay, okay, hidden mesh. Now the mesh is applied. Now to see that, just go to the plot control, style, size and shape, just on this display of element. Okay, so elements are displayed, so you can see here in a 3 dimension. Okay, so basically we are giving the circular cross section. You can go to the plot and multi-plot. So if ELKN, so element, line, key points and node, all these are active, then we have properly created the model. Now after meshing, we have to apply the boundary conditions. So select the define load, apply structural and displacement on node. On this node, displacement will be 0, so all degrees of freedom are 0. It is a fixed point. On the second, we have to apply the force on node. So load is a 10,000 Newton. Okay, now you can take the screenshot here. So you can use the snipping tool. Let's take the screenshot, and in the report, in the load, this load and displacement, you can add this. Okay, after the load, go to the solution, solve current ls. The solution is done. Go to the general post processor, plot result, contour plot, nodal solution, degrees of freedom, x component. So you can see the deformation. Also you can list the results, nodal solution, degrees of freedom, x component. So for the node 1 it is 0, node 2, and this is for the node 3. All these are in millimeter. If you want to see the stresses, load, results, element solution, stress, x component. List, results, element solution, stress, x component of stress. For the stress result, in the contour plot, go to the element solution, select the x component of stress. So you can see the stress values. This blue color indicates the value is 7.96 Newton per mm square. The red color indicates the value is 31.8558 Newton per mm square. Okay, if you want the list the result, go to the results and element solution, select the x component of the stress. Okay, so here you can see for the element 1, section ID is 1, all the values are same. So basically section number, section node means when we create the beam element, it automatically split that cross section into a number of sections. Okay, so it is a by default setting. For the node 2, the value of stress is, you can see here, 31.85 Newton per mm square. Okay, so here we have the element 1 and 2 only. So this is first element, this is the second element.